Welcome back. This is in continuation to the previous lecture. We will try to solve a problem on the two sample technique for determining the impedance phasor. Now, if you see the problem, you have been given the signal frequency, the sampling frequency, and also two samples of voltage and two samples of current. And we will try to determine the value of the impedance phasor. Now, let me write them again. See, this is the signal frequency, 50 Hertz. So, omega will be 2 pi f0, which is equal to 314. Sampling frequency is given as 1600 Hertz. So, T delta T will be 1 by Fs. It is 1 by 1600. It will result in, I have my calci, so don't forget to bring your calcis to the class. So it is 625 microseconds. So with the help of these two, first of all, let us try to determine the peak value of voltage. Vk has been given for us 110.838. I'll take this one as Vk plus 1, 117.677. So Vmax is equal to right. So this is the formula. Now don't forget that this is in radians because omega is in radians per second. So while doing the problems, don't forget about that. So if you want an easy solution, you better do this one earlier itself. This is 314 radians per second into 625 into 10 to the power of minus 6. This is radians. If you want to convert it into degrees, you multiply it with 180 by pi. So it will be better if you do it prior itself. So I'm doing it 314 into 625. So its value is 11.24 degrees. So this will help me out now. So Vmax, if I substitute these things, it is 110.838 whole square plus 117.677 minus 110.838 cos 11.24 by sine 11.34 whole square, right? So let me solve this one. So its value is 119.849. This is the value of Vmax. So I can do the Imax also similar way. See, Imax is also square root of Ik square plus Ik plus 1 minus Ik cos omega delta t by sine omega delta t whole square. So this is Ik and this is Ik plus 1. Two samples of the current signal. This we have obtained omega delta t in the previous case, so I am applying the same here. Right, so let me calculate this one again. So its value is somewhere around 12.00 amperes. So this is your Imax. Now, if I want magnitude of impedance, then it is Vmax by Imax. Vmax, I have obtained it in the previous case. It is 119.849 by 12. So this is 9.987 ohms. This is the way how we calculate the magnitude of impedance. Now this particular, I have tried this particular method and the previous two methods also. This particular two sample technique gives us closer values when compared to the previous derivative values. You can try it with any data which you do have. You choose the same data and you try this three techniques and you find out which one is closer to you. Now we will also try to determine the phase value also of the impedance. Now, the phasor of, if theta is the phase angle, then cos theta. So this is the phase angle of your current. I am assuming that theta is the phasor difference between V and I. So cos theta, the formula, it is IK VK plus IK plus 1 VK plus 1 minus IK VK plus 1 plus IK plus 1 VK cos of omega delta t by Imax Vmax sine square omega delta t. So I'll apply the data which I have obtained so far. So IK, this is IK, this is 11.089 into 9.982. Sorry, this is 110.838 plus 9.982 into 17.677 minus, this is 11.089 into 117.677 plus 9.982 into 110.838 cos of, this we have already obtained, it is 11.24 by Imax value I have already obtained, it is 12, it is 119. Let me check, 119.849 into sine square 11.2, right? This is the calculation which you are supposed to do. Let's try this one. So this is 2403.734 minus this is 2411.305 to cos of 11.24 by, this is 12 into 119.305. This is 1431.66 sine square 11.4. Now let's try to So its value is somewhere around 0.705. So this is the value of cos theta. So theta value is cos inverse of 0.705, and here you will be getting somewhere around 55 degrees. So this is the way how we determine the value of the phase angle of impedance using the two sample technique. I hope you have understood this particular problem, and we will see more problems in the class. Thank you.